Welcome to episode 473 of AI Brief.
Imagine walking into your bedroom after a long day. In the corner, there's this sleek, modern, minimalist floor lamp casting a warm glow. But the moment you leave the room, the chassis of that lamp quietly splits open.
Right, mechanical arms extend outward, reach onto your bed, precisely fold your laundry, and pull up the duvet.
Exactly. And by the time you walk back in, the arms have retracted, the chassis is sealed, and it's just a stylish lamp again. Today, you are getting a roadmap to the absolute bleeding edge of machine capabilities.
We are unpacking ChatGPT's brand new $100 per month Pro plan. We're tracking a sudden, massive explosion in physical robotics from that home appliance disguised as a floor lamp we just mentioned to highly athletic humanoids running downhill.
And finally, we're breaking down 4 trending AI productivity tools designed to completely restructure how you approach your daily workflow.
Let's jump into the software side first. Because the intelligence landscape right now is, well, it's defined by an escalating arms race in coding tools. OpenAI just executed this highly calculated maneuver by introducing a new $100 per month Pro plan for ChatGPT.
It's a fascinating pricing tier. It sits right between the $20 plus plan and their unlisted $200 top tier plan.
Wait, $100 a month? I'm on the $20 plan and I barely ever hit my message limit. Who is actually burning through enough queries to justify a 5 times price jump? Who is this precision strike aimed at?
It's aimed entirely at high-intensity professional developers. To understand why someone pays that much, you really have to look at the underlying mechanics of how these large language models process code. The core value proposition here is capacity. Specifically, it offers 5 times more capacity for Codex, which is OpenAI's dedicated coding tool.
Oh, I see. Because when you're writing an email, you're only setting the model a few paragraphs of context, right?
Exactly. That's a tiny amount of data. But when a developer asks the model to debug a complex logic error, they aren't just sending one line of code. They are often uploading entire repositories, massive libraries of interrelated files, so the model can understand the global architecture of the software.
So they're eating up massive amounts of computational power with every single query, just to give the AI the background context it needs to find a single bug.
Precisely. The token count, which is how AI measures data, it absolutely explodes. During an intense software development sprint, a developer might query the model hundreds of times an hour, asking it to refactor entire databases. Under the standard $20 plan, hitting a usage cap during a deep flow state creates an immediate, frustrating bottleneck. You're forced to just stop working.
You completely lose your momentum.
Right, so providing a 5 times multiplier effectively removes that friction.
Think about the target audience through the lens of a fitness analogy. The $20 plus plan is your standard gym membership. You get access to all the machines, it keeps you fit, but during peak hours, you might have to wait your turn, and you're largely directing your own workout.
That makes sense.
But the $100 Pro plan is like booking dedicated, unlimited personal training time for an intense, high-capacity athletic camp. You're paying for immediate, unconstrained access to heavy lifting capabilities without ever having to wait in line. You're paying for the complete absence of limits.
And the business implications of this strategy reveal a broader market dynamic. This is a direct competitive strike against Anthropic. Anthropic already established this specific price point by offering a $100 per month option for Claude, their flagship model.
So by matching this exact tier, OpenAI is aggressively ensuring they don't lose power users to a competitor offering higher usage limits. It's a territory grab.
It is. AI companies recognize that professional developers are the most valuable demographic to capture right now. Locking in the power users means locking in the individuals who are actively building the next generation of software products on top of these ecosystems. Once a developer builds their workflow around Codex, they are highly unlikely to migrate to another platform.
It's a battle for long-term platform dominance, disguised as a simple subscription tier. But, this massive computational intelligence we just discussed, it's beginning to leap from the cloud directly into the physical geometry of our living spaces. So let's take a breath here and deliberately slow our pace down. We need to transition from the rapid-fire digital world into physical space, examining how this digital code is acquiring tangible form and changing the texture of our daily environments.
The integration of robotics into domestic spaces requires overcoming significant psychological and aesthetic barriers. A Palo Alto startup named Syncere has approached this challenge with a highly innovative design philosophy. Their creation, the Lume robot, recently went viral because, well, it refuses to look like a robot.
Right, as we described earlier, it's a home robotic system meticulously disguised as a sleek, high-end floor lamp.
Exactly. The engineering behind Lume is genuinely remarkable. While it stands in the corner of your bedroom looking like a piece of modern furniture, its internal architecture houses highly articulate mechanical systems.
But how does it actually know how to manipulate fabric? I mean, folding a shirt is incredibly complex because fabric constantly changes shape. It's not like moving a rigid box from point A to point B.
That is the core technical hurdle. Rigid object manipulation is easy. Deformable object manipulation, like folding laundry or making a bed, is a nightmare for traditional robotics. Syncere is solving this using spatial mapping combined with advanced imitation learning. The robot scans the room to build a millimeter-accurate 3D map of its surroundings. It identifies the bed, the pillows, and the clothing.
So it's not just following a hard-coded set of instructions.
No, it relies on neural networks trained on millions of hours of video showing humans folding clothes. It understands the physical properties of the fabric and adjusts its grip and tension in real time as the fabric moves.
And then once the tasks are complete, the arms retract, the chassis seals, and it reverts entirely to its passive state as a functioning light fixture. Pre-orders are actually open now, shipping this summer.
Syncere's approach represents a brilliant market strategy. Historically, bringing robotics into the home has failed because the machines look like industrial equipment. They feel alien. By wrapping advanced kinematics in the visual language of high-end interior design, Syncere is sneaking robotics into the home.
They're betting that the trick to mainstream adoption is aesthetic and visibility.
Yeah.
The machine has to feel like it naturally belongs before you allow it to manipulate your personal belongings.
Yeah.
But the contrast in how companies are attempting to conquer the hardware market is staggering. I understand the appeal of an invisible robot, but does anyone actually want a highly athletic humanoid running around their property?
It's a wild shift, because while Syncere is building stationary lamps that gently fold your shirts, Unitree is taking an entirely different, highly overt approach. Next week, they're launching their most affordable humanoid robot globally on AliExpress, targeting North America, Europe, Japan, and Singapore.
And the price point is what, $4,370?
Yes, and traditionally, humanoid robotics with any degree of dynamic mobility have been priced in the hundreds of thousands of dollars, relegated to research labs or heavy industry. Offering a fully functioning humanoid for the price of a used sedan completely alters the consumer landscape.
What's driving that massive price crash?
It's driven entirely by the commoditization of underlying hardware components like LiDAR sensors and high-torque joint actuators, which was fueled by the electric vehicle and smartphone supply chains.
But this particular model isn't built for slow, methodical household chores. It is engineered for dynamic, sport-ready movements. It's capable of executing cartwheels, maintaining its balance while absorbing physical impacts, and running downhill. How does a bipedal machine run downhill without immediately tumbling over?
It comes down to dynamic balancing algorithms. A traditional, older robot walks by moving a rigid leg, planting it securely, and then slowly shifting its center of gravity. It's incredibly clunky. Unitree's models are essentially in a constant state of controlled falling.
Control falling.
Yeah. When the humanoid runs downhill, its internal gyroscopes and algorithms are calculating its momentum, vector velocity, and the angle of the terrain. It adjusts the electrical current sent to the motors in its knees and ankles hundreds of times per second to catch itself on the next step. It's a highly complex physical ballet computed in real time.
You really have to consider the incredible split in these two distinct philosophies for cracking the mainstream Western market. On one side, we have a machine designed to be completely invisible, rooted to one spot in your bedroom, handling delicate fabrics. On the other side, for a remarkably accessible price, you can order a highly athletic, untethered humanoid that arrives in a crate and can sprint across your backyard.
And Unitree is aiming to ship between 10,000 and 20,000 of these units in 2026. We are about to test, at scale, whether the average consumer has a genuine appetite for a bipedal athletic machine operating on their property.
This progression accelerates even further when we examine the long-term roadmap detailed by Clone Robotics. Their CEO, Dhanush Radhakrishnan, has publicly unveiled a timeline to launch what they call synthetic humans by the year 2028.
Right, the core product, named Protoclone, discards the traditional robotic architecture of rigid metal chassis and geared motors entirely. Instead, it's built upon polymer skeletons that eerily replicate the exact anatomical structure of the human musculoskeletal system.
The engineering goal here is absolute biomimicry. But why abandon electric motors? We just talked about how efficient those high-torque actuators are for Unitree. Why try to rebuild a human skeleton out of plastic?
Because electric geared motors are rigid. If they hit an unexpected obstacle, they apply full force until they either break through the obstacle or strip their own gears. Human biology is vastly superior for interacting with the unpredictable physical world because our muscles possess elasticity.
Ah, so they're utilizing artificial muscles.
Yes, actuators that contract and expand identically to human biological tissue. These are typically pneumatic or hydraulic synthetic fibers layered over the polymer bones. They provide compliance, meaning the limb can physically yield to pressure, making the movement incredibly fluid and adaptable to complex environments.
The stated objective is to manufacture a complete, full-scale musculoskeletal android for under $20,000 at mass production scale. Connecting these three distinct robotic developments really reveals the ultimate trajectory of the industry.
We are observing the evolution in real time. It begins with single-purpose appliances cleverly disguised as furniture, like the Lume robot. It advances to affordable, dynamically balancing athletic platforms, like the Unitree models. The terminus of this arc is true musculoskeletal replication, creating machines that map perfectly to the physical constraints and capabilities of the human form itself.
We're talking about removing physical friction with these synthetic humans, but the friction most of you deal with every single day is not folding laundry or running downhill. It is navigating your desktops. Let's transition directly to the immediate practical software that you can install on your machines right this second. The ecosystem of AI productivity tools is expanding rapidly, and we've isolated 4 specific applications designed to fundamentally optimize your daily output.
The first tool is called Clicky. The core concept behind Clicky is spatial convenience. Instead of navigating away from your current workspace to open a separate browser tab or a dedicated chat application, Clicky operates as a constant digital presence natively integrated into your Mac. It literally follows your mouse cursor.
Imagine you're reviewing a complex spreadsheet or reading a dense PDF. Wherever your cursor hovers, Clicky is immediately accessible right there on the screen. But how is it actually interfacing with the documents? Is it taking screenshots of what you're looking at?
It uses advanced screen parsing and computer vision. The application continuously reads the underlying context of the active window on your operating system. Because it has local permissions, it understands the text blocks, the data tables, and the visual elements rendered on your display.
So you can ask it to summarize the text you're highlighting or calculate figures on the fly.
Exactly. Without ever breaking your visual focus or context switching between windows, it's a pervasive intelligence layer that maps to your physical mouse movement.
If Clicky is acting as a constant digital companion, Inbox Joy is serving as your personal bouncer. As professional networks expand, social inboxes often become cluttered with spam, low-value inquiries, and automated solicitations. It obscures the truly important communications.
Inbox Joy is an AI-driven filter specifically engineered for the noise of social direct messages. Older spam filters relied on rigid, hard-coded rules. If an email contained the word crypto or the phrase act now, it got flagged. But human communication is highly nuanced. A simple keyword match is completely insufficient for modern platforms. Inbox Joy utilizes localized large language models to analyze the semantic intent of incoming messages.
So it actually understands the context of the conversation.
Precisely. It reads the message the way a human assistant would. It understands that "let's sync up next week" coming from an established industry peer is a high-priority message, but that exact same phrase coming from an unknown account pitching a B2B software product is noise. It categorizes and filters the noise before it ever triggers a notification on your device.
If Inbox Joy is filtering the noise out of your personal communications, Avotix is filtering the noise out of the entire internet for your business. Avotix functions as a competitive intelligence analyst, running perpetually on autopilot. Tracking competitor pricing changes and market positioning traditionally requires thousands of hours of manual labor.
Avotix automates this entire intelligence gathering apparatus. It continuously monitors the digital footprints of your designated competitors, synthesizing vast amounts of unstructured data. A competitor might launch a new feature in a buried blog post or tweak their pricing tiers without making an announcement. Avotix scrapes these disparate data sources and uses natural language processing to extract the specific variables that actually matter to your business strategy.
It turns unstructured internet chaos into clean, actionable dashboards. If a competitor quietly alters a pricing tier, Avotix identifies the anomaly and alerts you immediately.
The final tool, WhisperFlow, attacks the physical bottleneck of the keyboard itself. WhisperFlow is a ubiquitous dictation engine designed to work seamlessly across every single application on your operating system. The objective is to permanently bridge the gap between the speed of human thought and the mechanical limits of typing.
Most professionals type at a fraction of the speed they speak. WhisperFlow allows you to stop typing entirely and begin speaking your emails, code documentation, and reports up to 4 times faster than manual data entry. But what makes this different from the standard voice-to-text button that's already built into your phone?
The difference is system-level integration and the underlying transcription models. Standard dictation tools are often siloed, and they rely on older speech recognition algorithms that struggle with complex industry jargon or rapid speech. WhisperFlow leverages cutting-edge acoustic models which process audio with near-perfect contextual accuracy. Because it operates at the root operating system level, it doesn't matter if you're in a messaging app, a word processor, or a coding environment. The dictation flows instantly and accurately wherever your cursor is placed.
The overarching theme across all these developments is the systematic removal of friction. It fundamentally changes how we value our time and our physical space. Consider the trajectory we've mapped out today. We are already normalizing the idea of paying a $100 monthly subscription for an invisible software intelligence that accelerates our complex coding tasks.
We are currently pre-ordering robotic floor lamps that possess the kinematic intelligence to manipulate our physical garments. We are replacing the physical friction of typing with the speed of thought.
As these vectors of pure intelligence and physical embodiment inevitably merge, it forces a profound shift. It leaves you with a critical question to consider as manufacturing costs plummet, as artificial muscles replace rigid motors, and as the capabilities of these models compound. How long until having a fully autonomous synthetic human operating inside your house is just treated as another standard monthly utility bill?
If you want to stay ahead of this accelerating curve and understand exactly where this technology is heading next, share this podcast with someone who wants to stay ahead of the AI curve, and be sure to follow us.
Thank you for joining us today